Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss one question on normal probability distribution which was asked in GTU Winter 2019 exam. Now if you have not seen my lectures number 1 to 7 on normal distribution, I suggest you to watch these lectures first before going for this lecture so that you can understand all the concepts of normal distribution very well. Okay, so fine, we start with this question. It is given that distribution of height of 1000 soldiers is normal distribution with mean 165 centimeters and standard deviation 15 centimeters. How many soldiers are of height less than 138 centimeters, more than 198 centimeters, and height between 138 and 198 centimeters? So it is already given that this is the problem of normal distribution with random variable as height of a soldier. So first we write that it is given that capital X is random variable, capital X is a height of a soldier, and it is given that mean of X is mu equal to, mean is 165 centimeters and standard deviation is 15 centimeter. 165 centimeters and standard deviation sigma is 15 centimeters. So it is given that X is a normal random variable with mean 165 and variance sigma square, that is 15 square. Now using this information we have to find out number of soldiers of height less than 138 centimeters. So to find out number of soldiers having height less than 138 centimeters, first we decide the probability of height of a soldier being less than 138 centimeter. So in part 1, first we find the probability that height of a soldier is less than 138 centimeter. Height of a soldier is less than 138 centimeters. So this we can represent as height is denoted by capital X is less than 138 centimeter. So as we know, first we have to standardize this random variable. So for that we consider subtraction of mu from capital X as well as subtraction of mu from 138, and we divide both sides by sigma. Now as we know that this X minus mu over sigma is standard normal random variable, and here we substitute values of mu and sigma which are 165 and 15 in this case. Now if you simplify, this is going to be probability that Z is less than, if we simplify this, it is going to be Z is less than minus 1.8. So we have to decide this probability that capital Z is less than minus 1.8. Now they have given probabilities of standard normal random variable lying between 0 and 1.8 and 0 and 2.2. It is given that probability that Z lies between 0 and 1.8 is 0.4641. So these two table values are given. So first we use this table value for first part. Probability that Z lies between 0 and 1.8 is 0.4641. So this is the standard normal curve. We are familiar with this curve. It is a bell-shaped curve, symmetric about y-axis, and probability that Z lies between 0 and 1.8 is given as, this is given, Z lies between 0 and 1.8 is 0.4641, and we are interested in this probability that Z is less than minus 1.8. So because our curve is symmetric, suppose minus 1.8 is here. So this probability is nothing but area to the left side of minus 1.8. Now if we observe, then by the symmetry of curve, this area to the left side of minus 1.8 will be equal to area to the right side of 1.8. Okay, this area shaded by blue lines are same due to symmetry of this standard normal curve. So this we can write as probability that Z is strictly greater than 1.8. Now again we know that total area under the standard normal curve is always 1, and standard normal curve is symmetric about y-axis. So if we consider this area, probability that 0 less than z less than infinity, then it is area to the right side of y-axis. So this is nothing but 0.5, because it is half of the total area and total area is 1. So half of the area is nothing but 0.5. Now we are interested in this area. This is nothing but probability that capital Z is strictly greater than 1.8. So we know that this area to the right side of y-axis is 0.5, and we are interested in this area, and we have value of this area. Okay, so or we can observe that probability that 0 less than z less than infinity, this is nothing but probability that 0 less than z less than 1.8 plus probability that z is greater than 1.8. Okay, we are considering this interval from 0 to infinity is union of interval from 0 to 1.8 and 1.8 to infinity. So area between 0 and infinity will be equal to area between 0 and 1.8 plus area between 1.8 to infinity, that is z is greater than 1.8. Now this area is 0.5. This is given, this area is given, it is 0.4641. So this area probability that z is greater than 1.8 is nothing but probability that 0 less than z less than infinity minus probability that 0 less than z less than 1.8. This area shaded by blue lines will be equal to total area to the right side of y-axis, which is probability that 0 less than z less than infinity minus this area shaded by green lines, area between 0 and 1.8. Now this area to the right side of y-axis is 0.5, and we are given this value, it is 0.4641. So we substitute here 0.4641, and if we simplify, we have 0.0359. So this is the probability that height of a soldier is less than 138 centimeter. So therefore the number of soldiers of height less than 138 centimeters will be equal to total number of soldiers into this probability that x is less than 138 centimeter. So this we have obtained as 1000 into 0.0359. So this turns out to be 35.9, which if we round up to 0 decimal places, we have 36. So there are 36 soldiers of height less than 138 centimeters. Now we move towards second part. In second part we are asked the probability that height is less than 198 centimeters, and we are given this probability that z lies between 0 and 2.2. So first we consider that second part, probability that height of a soldier is more than 198 centimeters, that is probability that capital X is greater than 198. Now we standardize this random variable. We consider x minus mu over sigma is greater than 198 minus mu over sigma. Now x minus mu over sigma is nothing but probability that z is greater than this. We replace by z, and here we substitute mu equal to 165, sigma is 15, and if we simplify this, we have probability that z is strictly greater than 2.2, and we are given this probability that z lies between 0 and 2.2 is 0.4861. So using that probability we will decide this probability that z is greater than 2.2. Okay, so for that we again sketch that standard normal curve. Okay, it is a symmetric curve about. Okay, so roughly we sketch this symmetric normal curve. Suppose this is 0, here we have, suppose this point is 2.2, and we are given probability between 0 and 2.2. This is given probability that z lies between 0 and 2.2 is given as 0.4861. So first we mention that probability area between 0 and 2.2 is 0.4861, and we are interested in the area to the right side of 2.2. So we are interested in this area to the right side of 2.2, and this total area to the right side of y-axis is 0.5, and we are interested in this area shaded by red lines. So if you can observe this, I can write as total area to the right side of y-axis, which is probability that 0 less than z less than infinity, minus area up to 2.2, area between 0 and 2.2. So this area shaded by red lines is nothing but total area to the right side of y-axis minus this area between 0 and 2.2. Now total area to the right side of y-axis is 0.5, and this area is given as 0.4861. Okay, and if you subtract this, you will have 0.0139. So this is very easy. Using standard normal curve properties and using given areas, we are able to decide required areas. So probability that z is greater than 2.2, this probability is shaded by red lines. This probability is nothing but probability between 0 and 2.2, and we know that this total probability or total area to the right side of y-axis is 0.5, and that area is addition of these two. Okay, so this area is 0.5 minus this area. So this is the probability that height of a soldier is more than 198 centimeters. So therefore the number of soldiers of height more than 198 centimeters will be equal to 1000 into probability that x is strictly greater than 198, which we have obtained as 0.0139. so this is nothing but 13.9, which we round off as 14. So there are 14 soldiers of height more than 198 centimeters. Now we consider third part. In third part we are asked the probability that height is in between 138 and 198. Probability that height of a soldier is in between. Okay, let me check again. In part 3 we have to find the number of soldiers of height between 138 and 198 centimeters. So probability that height of a soldier is in between 138 and 198 centimeters. So this we can represent as 138 less than capital X less than 198, that is x lies between 138 and 198. So this is equivalent to, we standardize by considering mu is subtracted divided by sigma is less than x minus mu over sigma is less than 198 minus mu over sigma, and we substitute values of mu and sigma. Here mu is 165, sigma is 15. This is random variable capital Z. Here 198 minus 165 divided by 15. And we have done these calculations in part 1 and 2. This turns out to be minus 1.8 and this turns out to be 2.2. So this we can rewrite as probability that Z is less than or equal to 2.2 minus probability that Z is less than or equal to minus 1.8. And if we consider this probability, this we have already obtained in part 1, probability that Z is less than or equal to minus 1.8. Okay, if we observe this, probability that Z is less than minus 1.8 and it is equal to probability that Z is greater than 1.8, and it is nothing but 0.0359. Okay, this probability we have obtained here, so that we write directly from part 1 0.0359. So first I write this probability 0.0359. Now I am interested in this probability that Z is less than or equal to 2.2. So for that I come here again. I am interested in the probability to the left side of 2.2. I am interested in this probability. If I consider this area to the left side of 2.2, this whole area is nothing but probability that Z is less than or equal to 2.2. So this area is nothing but addition of these two areas, area up to 0, this area plus area between 0 and 2.2. Okay, I can write probability that Z is less than or equal to 2.2 equal to area between minus infinity to 0 plus area between 0 less than Z less than 2.2. Area to the left side of 2.2 is addition of area from minus infinity to 0 plus area from 0 to 2.2, and this area is the area to the left side of y-axis, which is 0.5. So we have 0.5 plus area between 0 and 2.2. So this we can write directly as, or we can write one more step, area from minus infinity to 0 plus area from 0 to 2.2. Okay, we can understand here also. Okay, suppose we have 2.2 here, we are interested in the area to the left side of 2.2, so we are interested in this area. Now area up to 0, that is this area, is nothing but 0.5, and this area is area between 0 and 2.2, which is given as 0.4861. So this we can write as 0.5 plus 0.4861, this is given in our question, minus 0.0359. So if we simplify, this becomes 0.9502. So this is the probability that height of a soldier is in between 138 and 198 centimeters. So therefore the number of soldiers of height between 138 centimeters and 198 centimeters will be equal to 1000, that is total number of soldiers, into probability that x lies between 138 and 198. So this is nothing but 1000 times 0.9502. So this is nothing but 950.2, that is approximately 950. So there are 950 soldiers of height between 138 and 198 centimeters. Okay, so this is the solution of this question. In this question, all we are using is the properties of standard normal curve. Okay, so we will always remember that if we have normal probability curve, and if we consider its shape, then it is a bell-shaped curve. It is always symmetric about y-axis. Area to the left side of y-axis, that is this area, probability that minus infinity less than z less than 0, and this area to the right side of y-axis are always equal. Okay, these two areas are always equal, and equal value is 0.5 because sum of these two areas must be 1. So using this property we can easily find out required probabilities using standard normal probability table or standard normal probability table values. So here they have given already table values. Table values are given from 0 to 1.8 and 0 to 2.2. Okay, so using these table values we are able to decide the required probabilities. Okay, so if you are watching this lecture series first time, I suggest you to watch lecture number 1 to 7 on normal probability distribution. In these lectures I have discussed how to use normal probability table values to decide required probabilities. So this is all about today's session. I hope you like it. Thank you very much.